And continuing this topic, slope that is equal to the formula for slope that is equal to tan theta. Okay. And what is the slope? Slope is just an angle. Have a look. When you the graph, for the Ohm's law, there is del V versus that. There's a straight line. That's a straight line. And slope, that's the angle. It just make with the x-axis. This is the angle, and this is called theta. The formula for slope that is tan theta, and that is equal to, this is y-axis, this is x-axis, that is equal to y2 minus y1 divided by x2 minus x1. Okay. Slope, the formula for slope that is equal to tan theta, and that is equal to y2 minus y1 divided by x2 minus x1. Have a look over here. Here it is del V versus I. That is equal to y2 minus y1. This y-axis, this is equal to del V. I will write it del V divided by x-axis. This is equal to I. So slope is equal to del V upon I. Slope is equal to del V upon I. And look here. Del V upon I, that is equal to resistance, that is equal to R. So I will write slope is equal to R. R is or resistance. So the slope for Ohm's law, that is equal to or resistance. The slope of del V versus I just gives us a resistance. Just gives us resistance. So we say slope that is equal to or resistance. Slope is equal to this important topic of this important term here. Slope of del V versus I, which is current. And the slope for Ohm's law, that is equal to resistance. That is equal to resistance. Now, moving ahead, I am taking here a conductor. Just have a look. Just have a look over here. If this is a conductor, okay, and its length is L, this area of cross section A, okay, and here current is flowing in this direction. Look over here. This is a conductor. Its length is L, area of cross section that is equal to A, and current I is flowing inside. Okay, and we know the formula for resistance R, that is equal to rho into L divided by A. This is the resistance, which we see it obstructs the flow of current. It is the opposition to the flow of current. Here, this rho, this is called rho. That is equal to resistivity. Resistivity. Okay. Pronounced as rho. And is equal to resistivity. R is equal to rho into L divided by rho. This is called a resistivity. It is a property of a material. It is the property of a material. L, it is the length of the conductor. A, this is the area of cross section. It's called a resistance. This is resistance. Now have a look here. If we have been asked to find the resistivity of a wire, what do we do? Let's have a look. If this is a wire, okay, if this is a wire, we have been asked to find the resistivity of this wire of length L and area of cross section that is equal to E. Area of cross section that is equal to E. We have been asked to find the resistivity of this wire. What do? We cut a piece of wire. We cut a piece of wire having length 1 meter and area of cross section 1 meter scale. Okay, I will draw it here. One meter length and area of cross section, that is 1 meter scale. This is a wire. We have been asked to find the resistivity of this wire. What do? We cut a piece of wire of length 1 meter and area of cross section 1 meter square from this wire. Okay. And now, what do? We connect the two ends. Let's have a look. proportion of 1 volt. Okay. Have a look. We have to find the resistivity. We have to find the resistivity of this wire. What we do, we cut a piece of wire of length 1 meter and area of cross section 1 meter square from this wire and connect to a portion of 1 volt, to a portion difference of 1 volt. Okay. Now, knowing the formula, R is equal to V, R is equal to del V upon I to find the current. Okay. To find the resistance, we have the formula here. I may write it here. R is equal to rho into L divided by A. Have a look over here. R is equal to rho into L divided by A. And I will write it here. R is equal to rho into, what is L? L is the length of the wire. Length of wire, that is 1 meter, divided by area of cross section, that is equal to 1 meter. 1 divided by 1, that is equal to 1. R is equal to rho. Just have a look here. R is equal to rho. That means, what is R? That is resistance. What is rho? That is resistivity. That means, resistivity is the resistance of a wire, of a conductor. Or resistivity is the resistance of a wire of length 1 meter and area of cross section 1 meter square. So to define resistivity, we can say resistivity is the resistance of a wire whose length is 1 meter and area of cross section is 1 meter square. Then we can find the resistivity. Resistivity, its symbol is this. It's called a rho. That is equal to the if we have to define resistivity. We can say that resistivity is the resistance of a conductor, of a wire whose length is 1 meter and area of cross section, that is equal to 1 meter. So okay, now let's have a look. If we have to find a resistivity here, a resistivity will be equal to R into A divided by L. Isn't this? R into A divided by L. So resistivity will be equal to R, that is ohm, into A, that is meter square, divided by L, that is meter. Meter and meter, here it comes ohm meter. Ohm meter. So the unit of resistivity, that is ohm meter. That is ohm meter and represented by this ohm meter. This is the unit of resistivity. This is the unit of resistivity. Resistivity, that is the property of a material. Resistivity is the property of a material. To define the resistivity, we can say it is the resistance of a wire whose length is 1 meter and area of cross section is 1 meter square. The unit of resistivity, that is ohm meter. That's ohm meter. It was all about Ohm's law and current. Keep watching Ohm's law and resistance. Keep watching Asif sir's classes. Thank you. Have a nice day.